Hello ladies and gentlemen, this is Workene. In today's video record, I'm going to talk about the measure of central tendencies. So to start, before starting, with explaining about what this measure of central tendency is, let me ask you some basic questions as a brainstorm. It may help you as a brainstorming so that you may think to answer or before you watch this video record. Therefore, okay, basically, what is the measure of central tendency? What is the meaning of the measure of central tendency? What does it mean conceptually? How you understand the measure? Do you have any idea about these issues, the measure of central tendencies? What are the indicators that we use in order to do this measure of central tendencies? Do you have any idea about mean, median, mode, geometric mean, harmonic means? There are different type of mean. Do you have any idea about these means? And we have median and mode as well as a measure of central tendency. Do you have any idea about these things? Do you know how you make interpretation of them? Do you know how you can calculate them? For what reason or purpose you are using those measure of central tendencies? These are the basic questions that you need to stop this watching this video record and try to answer it before you watch it. And after you watch it, ask yourself whether you answer it correctly or not. Thank you very much. Let's continue explaining about what the measure of central tendency is in detail by sharing my slide. So today I'm talking about the measure of central tendencies. Okay, conceptually, what is the measure of central tendency is? The measure of central tendency is it is one of the statistical tools that we use to summarize the data. Of course, we make summarization of the data by calculating, like for example, average of those data, the mean of those data, or by identifying any typical values that can represent that data set. You may have, for example, the data set, the total data set you have, let's say, or the data point or the data set is 15 number, and the number of observations are 15. Then you can calculate the mean for that. That mean actually represents that data set. Even you can calculate the medians or the mode. So the measure of central tendency is one of the tools that we use to summarize the data points or the data sets by calculating the average or by identifying one of the typical representative values in that data set. Maybe the representative value may be the mean, or it may be the mode, or it may be something else. So you need to identify some data points, some data values that can actually represent that data sets, that data distributions from in some ways. Maybe it is a middle value, maybe it is something that happened many times, or whatever it is. So that is the measure of central tendency. It is one of the tools that we use to summarize the data. That's one thing, numerically. So data can be summarized graphically in the table forms, sometimes numerically. So the measure of central tendency is one of the tools that we use to summarize the data numerically. Sometimes we calculate the mean, and the mean represents the average of that data status, or sometimes we can select the middle values, which is the median, and sometimes we can select the mode, which is data that happen many times in that data status, the one that has high frequencies. That is the concept of central tendency. It's about summarizing the data sets by selecting one typical values that can represent that data distributions or that data sets or that data points, or just we can calculate the mean, the average, the average, right? So let's talk about one of the indicator of the measure of central tendency, which is arithmetic mean or just the mean. It is the most important measure of location. It is the mean. It is the most important measure of location. It is the average value of those variables. The mean provides a measure of central location for that data. It is the measure of the central location. It is the middle value, the mean. It is the average value for that matters. The way we can calculate sample mean is just very simple. It is a summation of each variables divided by the number of the observation. It is summation of xi divided by the number of observation. Of course, these are some of the property of the means. mean x1 plus k, x2 plus k, x3 plus k. Just adding some constant number on each variables actually affects the mean in these ways. Old mean plus k. Just this old mean plus k. For the other one, if you subtract some constant number from each data value or from each data point, then the impact on the mean is old mean minus k. On the other hand, if you multiply each data point by one constant number, then its effect on the mean is just old mean times k. So these are some of the property of the means. I hope you understand what mean is. Very simple mean. This is just simple mean, a common mean or the usual mean that we encountered. The other one is weighted mean. Sometimes each data point, each data value may have different weights. In that cases, if there is difference in the weights, then the type of the mean that you need to calculate is not the common mean, the usual mean. Rather, you need to calculate the weighted mean. Then what is the weighted mean? It is used when individual values do not have equal weights. If individual data point, individual data value have different weights, for example, you may take, like in this semester, 6 or 5 or 4 courses, let's say 4 courses. But the credit hour for each course is not the same. Some of them have 4 credit hour, some of them have 5 credit hour, some of them may have 3 credit hour. Therefore, the weight for each course is not the same. There is a difference in the weights. Therefore, the way you calculate the mean is you have to calculate the weighted mean, not the usual mean or the simple mean we know. So how you get the weighted mean? The weighted mean is actually summation of weight of that individual times the value of that data point over the summation of the weights. This is the formula that we use to calculate weighted mean. Example of weighted mean is computation of cumulative grade point average, CGPA, cumulative GPA. So I think all of you know how you calculate GPA, right? First of all, you need to get grade. Then maybe if you get A actually the weight for A is 4, right? The point for A is 4. Then you need to multiply this 4 by the credit hour of your courses. Let's say this course is let's say 5. The credit hour for this course is 5. Then you need to multiply 4 times 5. This is, we call it quality points. Then maybe you have another course, let's say another course that you are taking in this semester. For example, as a development policy student in these semesters, you may take like public administration, governance, and ethics. These are another courses. Like for example, institutional development is also, I hope, it is a course that you need to take in these semesters, right? So that the credit hour for each course is not the same. So it's the grade that you get times the weight for that course, then you need to sum them. This we call like multiplying the grade, your grade times the credit hours. We call this value as quality grade, right? Quality point or quality point. Then you need to get the summation of the quality point, and then you need to divide by the summation of the weights. So you need to apply these formulas, right, in order to calculate the weighted mean. So simply, if the weight for each data point is not the same, is not equal, then the type of the mean that you need to calculate is weighted mean, is not the general mean that you know. We can have other examples with, but the common one is, as a student, of course, cumulative gap. For example, sometimes you want to give some kind of, let's say, subsidies for the farmer. Then, the weight that you are going to give subsidy for the farmer may differ based on their living standards. Maybe you have category of social categories of your community or your classes. Some of them are poor. Then the weight that you are going to give for the poor is, let's say, it is 60%. 60% of the total subsidy will be given for the poor. But for middle income households, you plan to give them 30 point. And a 10 point is, or 10% is, let's say, for rich peoples. So that the amount of subsidy that you are going to give for this community is not the same, right? The poor is going to get 60%, 30% is for the middle income households, and the other 10% is for the rich ones. So that in order to calculate the mean, you need to use weighted mean approaches, right? Weighted mean approach, and then you need to calculate the weight mean. So this is one example. Another type of mean is grouped mean. Grouped mean. Of course, sometimes maybe your data is continuous, then you make like group, right? Group, and then if you want to calculate mean, you need to calculate grouped mean. The formula to calculate the grouped mean is, of course, the summation of the frequency of that classes or that interval times the midpoint of that interval divided by the number of observation. For example, for this data point, remember the audit time data values or data sets or data points. It is the number of the day that it takes for an institution to complete a year-end audit. So that we have these ranges or these classes from 10 days to 40 days, from 15 days to 90 days, from 20 days to 24 days, from 25 days to 29 days. And we have these ranges, these classes or these intervals. And then the midpoint for each interval is also very simple. It is summation of what? 10 plus 14 divided by 2. Add these two, divide by 2. 15 plus 19 is 34, divided by 2 is 17. 20 plus 24 is 44, divided by 2 is 22. 25 plus 29 is 54, divided by 2 is 27. 30 plus 34 is 64, divided by 2, it is 32. So the class midpoint is the average of the class boundaries. This is the lower boundaries or lower limit. This is upper boundary or upper limit, and then it is the average of the class limit. That is the class midpoint. It is an average, it means it is just you need to divide it by 2. So 10 plus 2, you need to add these 2 and then divide it by 2. The number of observation you have is 2. So that n is 2, in this case 1 and 2 here. 10 and 12, so that you want to get the middle values. That is the midpoint, the middle values. Sum them, divide by 2. And then you get the midpoint. Then frequency, this one is given. The number of times, or the number of frequency in this context is, it is like the number of data points that appear in that classes or in that ranges. From 10 to 40, there are 4 data points, or there are 4 institutions that complete annual auditing between 10 to 14 days. There are 8 data points in these ranges, or simply there are maybe there are 8 institutions that complete their annual auditing in these ranges. That is frequency is simply for continuous data point or for say type of group data. Frequency is simply the number of data points, the number of variables, the number of data values that appear in that ranges. So that from 10 to 40, there are 4s. From 50 to 90, there are 8 data points. From in the between to 20 to 24, there are 5 data points. And from 25 to 29, there are 2 data points. And from 30 to 34, there are 1, or we have 1 data points. So this is frequency. Then you need to multiply frequency times class midpoints. Just you need to multiply them, these two. 12 times 4, 48. 17 times 8, 136. 22 times 5, 110. 27 times 2, 54. 32 times 1, it is 32. Then you need to add them, summation. That is summation of f times m. F times m, summation of them, add them. The total number is 318. Then, in order to get the sample mean for group data, sample mean for group data will be, it is the ratio of this by this. 380 divided by the number of observation. n is 20 here. The number of observation is 20. It is given if you want, or summation of frequency actually give you the number of observation. So the sample is actually summarized at 19. Therefore, the average or the mean for this group data is 19. You see, we actually represent this data by a single value, and we call it a mean of group data. So that's very simple, isn't it? At this time, summarizing or trying to see what the distribution of that data set is, or one of the characteristics of that data point is it has a mean of 19. And you understand about that data, at least you know the mean for that data distribution, right? For that data set. So we summarized it by one single value, and that is 19. And we call this 19, it is a mean of group data. So, calculating the mean is very simple. Making interpretation for that is also very simple. The average data point in this case is 19. And one of the problems when we think about the mean is that if there is an outlier means it is a data point which is very far from the others, which is very far from the mean. Simply, the outlier is something very far from the other average, from the other data points. It is very far. It's not, in absolute number, it's not like, near the others. It is very far. It is an outlier. It is separated from the others. So if there is an outlier, that outlier directly affects the mean. So the mean is very sensitive for the outlier. And if there is an outlier, using the mean is misleading. Even if the range or the variation of the data is very big, the mean actually, like for example, in income of households, let's say there are 5 households in the data in that data sets. Maybe 4 of them, their income, let's say it is like 10 and 20. 2 of them get 20, 2 of them get 10, and one person get 500. Look, one person gets the 500, and the other 4 of them actually less than 20, 2 20, the other 2 10. That is income, let's say in dollar. And then if you calculate the mean, 10 times 2 is 20, there are other 2 20 40 60 60 plus 500, it is 560. 560 divided by 5, number of observation 1, right? And then divided by 5, and 60 by 5 is 12, right? 1 1 2. 560 divided by 5 is 112. So the mean for this data set is 112. You see, let's take a calculator to make a little bit very simple, to make it easy for you as well. Look, I have 5 individuals plus 2 of them get $10, the other 2 get 20, and the other get 500. You see, 560 divided by what? How many? 5. I want to get the average. It is 112. You see, the mean is 112. That means, in average, those households get $112 per day, let's say. But you see, only one person get 500, and this person pulled the mean to 112, but the majority of my people are getting 10 and 420. You see the effect of the outlier. 500 is very far from the others, and this actually pulled the mean, and it has misled the decision maker to make a decision. So if there is an outlier, using the mean is not appropriate. In that context, you better use the median. What is the median then? The median divided the set of the data into 2 equal parts. The median is the middle values. Very useful when there is an outlier. If your data set has an outlier, you don't need to use the mean. Using the mean is not appropriate. Therefore, what you need to use? The median. It is the middle value of the set of the ordered value. How you do or you get the middle values, the first task you need to do is that you need to order the data in ascending or in descending order. You have to order it. You have to arrange your data points in say ascending order, whatever, or in descending order. But the point is you need to order. That is the point. You need to order. If the total number is odd, the median is the middle value. For example, you have these data points. Let's say we have these data points 32, 42, 46, 46, 54. You see this is ordered. There are 246, so you don't have any other alternative other than listing them like this 46, 46. Then the middle value is 32, 41, 2, 3, 4, 5. Because it is odd, 1, 2, 3, 4, 5. 5 is odd, 7 is odd, 9 is odd, 11 is odd, right? If your data set are odd in number, then the median is the middle values. So the middle value is like 4. This is the middle value. Before this number, there are 2 data points. After this number, there are also 2 data points. Therefore, 46 is the middle values. So the median is 46. If the total number is even, the median is the mean of the 2 middle number. If it is even, the data point, the number of the total data set you have is even. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 is even. You see, 2 is even, 4 is even, 6 is even, 8 is even, 12, 10 is also even, 12 is even, 14 is even, 16, 18, 20, 22, 21, those things, those 22, those numbers are even number. Even number is the number that can be divided by 2. Odd number is the number that cannot be divided by 2. So if your data set is even, then you can't get the middle values because these 2 numbers are the middle values. So how you get the mean? The median is the mean of the 2 middle number. 1, 2, 3, 4, 5. This is the middle number. 1, 2, 3, 4, 5. This one is another middle number. These 2 are the middle number. And then you need to add them. You need to divide it by 2. Then that is the median. That is how you calculate the median. The mode. The mode is denoted by a set of numbers that values which occur with the greatest frequency. The mode is the one which has the greatest frequencies, especially for categorical variables. For qualitative variables, the way you summarize the qualitative variable is by calculating the mode. People are doing the mean, which is wrong. If your data is categorical, the number of male students, the number of female students in the class, the only central tendencies measure you can use is the mode, not the mean. Even you cannot use the median for categorical variables, specifically for nominal variables. You can use for ordinal variables. If it is ordinal variable, you can order it, therefore you can get the middle values. But if it is nominal, there is no way that you order like male and female, hair color, black, white, or those things. Type of fruits, you cannot order them as well in principle. Blood type, it is religion, they are nominals, there is no way that you make order, right? In that context, you better use the mode. The mode is one of the tools that you can use this in order to summarize your data points for categorical variable. A data set is called sometimes unimodal. Some of your data may have only one modes, one variables, one data point that appear many times. Bimodals. Maybe you have 2 numbers that appear many times in your data sets. Sometimes multimodal. If it is more than 2, you can call it multimodal, depending on whether it has 1 mode, 2 mode, or more than 2 modes. Unimodal, 1 mode. Bimodal, 2 mode. Multimodal, more than 2 modes. That is mode. It's very useful for categorical variable. If your data has an outlier as well, mode is good. It doesn't matter. Mode is good. You can use mode if your data has an outlier. If you suspect that there is an outlier in your data points, then use mode. Use mode, not mean. I hope you understand what the measure of central tendency is, isn't it? What is the measure of central tendency? It is one of the tools that we use in statistics to summarize the data by calculating or by selecting one average values, that is the mean, or by selecting one typical or exceptional or the representative value that can represent your data sets. Right? That is the measure of central tendencies. There are three number, commonly mean, median, and mode, but there is also geometric means, harmonic means, and there are those things additional. But for these courses, it is more than enough to know what mean, median, and mode is. Thank you very much for watching my video. See you in the next video. In the next video, I'm going to talk about the measure of relative locations. It includes percentile, decile, quartile. We'll talk about them in detail. Have a nice time. See you other time.